So this is the Supporting Innovation session, and we're going to have three contributions which talk about initiatives to enable and support, as the title says, support innovation. And we're going to have a North American perspective, a pan-European perspective, and a more global perspective involving countries across continents. So there's a nice combination there. And we have, as I said, three contributions, but 4 speakers. The second contribution will be split between 2 speakers of the global, or the more global collaboration, or the more global initiative that is being presented today. First of all, though, I will introduce Eric Boyd. Eric Boyd is quite a well-known figure in our community. He is a senior director at Internet2 for many years now. One particular piece of information that you might not know about Eric is that he has set himself a new objective to beat his child at chess over the next year or so. We wish him luck for that. I think it's a losing battle he's entered into, but if you'd like to start with your presentation now, that's fine.
Yes, absolutely. Thanks, Roberto. Yes, and my chess skills are not keeping up with a 9-year-old, so you can keep that in mind when you listen to this presentation. So I'm going to talk about Internet2's efforts to create a climate for innovation through our network service offerings. And in particular, at the end, I'll talk a little bit about an innovation awards, application awards program that we ran that was quite successful and might inspire other people to do it around the globe. So the general idea for Internet2, for those of you who aren't familiar, is to, just like the NRENs here in Europe, is to support new scientific discovery, new ways of doing networking, and really drive the innovation crank going forward in a way that really benefits society as a whole. Some of you will already know some of these things, but Internet2 is a fairly large community. We don't just do the network, we also do Net Plus services, and we bring together the whole, we also have a convening function as well, much as Terena does here in Europe. So it's really a large group, and it's been a fun community to work with over the past few years. So if you look at our partners and our members, that includes about over 200 universities and colleges, many affiliate members. We have state and regional networks as well all around the U.S., industry partners, et cetera. So it's really trying to bring that whole community together. We've been doing that since 1996. So about innovations, and that's really the talk. And a lot of these early slides sort of come from the inspiration of Dave Lambert, our CEO, who really pointed to the R&E community. If you look back historically, the R&E community in the US and around the globe has played a seminal role in the creation of the modern internet. And basically the applications that have made it such a transformative technology really have emanated from the university community. In the US, many of those leading universities created Internet2. And so the idea here, though, is to sort of make the observation that there was a lot of innovation coming out of the university community in the 1990s. In the 2000s, at least within the US, a lot of our networks were more focused on business models and the like. And what we really want to do is recreate that innovation spark. And so it's not just happening in Silicon Valley, but it's really, the next generation is emerging from our universities again. So let's talk a little bit about that. But first, let me give you a little bit of the driver. The driver is, of course, just how much investment, how much bang for your buck you get. This is a way to show it visually. So the original NSFnet, CSnet, ARPANET investment was less than $250 million. And some of these numbers are actually dated by 4 or 5 years, but the amount of value to the internet to the U.S. economy is is nearly 1.5 trillion, and it's probably way higher than that at this point. So from an investment standpoint, if we can continue to create this innovation fountain sort of coming out of the universities, it really benefits our entire economy and the global economy as a whole, and the same is true in other countries around the world. Basically these seminal investments put us way out in front, and that's really what we've been trying to do. I've said this before, and some of you heard me say it, that you may not know that Internet2's other name its original name is UCAID, UCAID, which stands for University Corporation for Advanced Internet Development. And you can kind of think of that as a goal statement for what Internet 2 is about. It's a university corporation. We're driven by the needs of the universities, but it's for advanced internet development. If all we're doing is being a nonprofit commodity provider, we really shouldn't exist. The goal is to advance the state of the art. So while we still have to run production networks that are high quality, we have to do so in a way that really shows the world how networking could be done that's different from what the commercial sector is doing. And just to sort of point out the fruits of this kind of innovation policy, you know, and the same can be said here in Europe and around the world, you know, there are all sorts of very familiar names in the networking arena that have their origins in universities. And we want to keep this going so that if you give this talk in 10 years from now, it's graduates coming out of today's universities that have built the next generation of names that we don't know yet. So how do we create an at-scale innovation platform going forward for the next era? And I'll go through this pretty quickly, and then I'll talk about some of the details of what we're actually doing. The three components that Dave Lambert laid out, I guess it's about 2 years ago, were really threefold. There was abundant bandwidth, there was friction-free science, and there was opening up the network stack. So the first one, the abundant bandwidth one, is really the idea that if we have limited bandwidth, people start designing around the constraints as opposed to saying, what new thing can I do? If you look at an example like file sharing, yes, there were all sorts of challenges about the fact that, you know, there were copyright issues and everything else, but fundamentally the transformation that happened with Napster and other types of things was they said, if we have an order of magnitude increase in the amount of bandwidth, wait a minute, it doesn't really make sense to supply media that could be supplied digitally in printed or stamped form. And so that's why you see the evolution away from books and the evolution away from CDs and DVDs into you know, anything that can be copied with zero marginal cost is now shared across the internet. And so, you know, that kind of transformation is only enabled by abundant bandwidth. Likewise, if you look at the emergence of Facebook, in many senses, Facebook emerged from the dichotomy between the fact that it was 56K to the home over your AOL modem, but it was, you know, 100 meg to your pillow in the dorm room, and all of a sudden that abundant bandwidth said, people said, hey, we don't just have to do text, we can do pictures, you know, and that's not a burdensome thing. And you could envision going forward that, you know, and we're starting to see the beginnings of this, that why do we have television? You know, everything should just come streaming over the internet because there's no reason why movies shouldn't be coming that way. That sort of thing as well. So that's a key piece, is how do we stay ahead on the abundant bandwidth piece. Another one is sort of opening up the network stack, which is sometimes defined as software-defined networking. But basically, if you think back to the 90s, people were still building routers on campuses. They hadn't become these mystical black boxes supplied by a few large vendors that supported dozens of legacy protocols, but yet were very, very difficult to change. So the whole concept of software-defined networking, which is sometimes equated with OpenFlow and is sometimes seen as a much bigger thing than that, and I think it should be the much bigger thing, is that if you want to create an environment for innovation, you need to have a way to continue to make the existing networks work while going forward, you need to be able to try things different. You know, if Roberto has an entirely different idea on how networks should operate, we ought to have a way to create an environment where he can show that in an at-scale environment and not just write a research paper. And so I'll talk about this at length coming up, what we're trying to do in this space, but the gist of it is basically how do you create virtual networks in a way that lets people try alternate network technologies without being sort of bound to the ever increasingly expensive traditional route approaches like routers going forward. And then the third one, and I think Greg can certainly talk about this, and you know, ESnet deserves a large amount of credit here, is in terms of support for data-intensive science. You know, the increasingly the way networks have been designed is, you know, you build these expensive research universities with all sorts of high-powered researchers who want to do all sorts of science, and then you design your campus network to support students with no concept of anything that they can watch cat videos on their phone. And so, you really want to have networks that are designed for friction-free science, that don't put up so many roadblocks in the form of firewalls that you can't really do high bandwidth data transfers. And so that's sort of the third piece. So there's really three components, we think, to that innovation story, and that's a lot about what we've tried to create going forward. And I think this is very synergistic, at least in the US. For a long time, there hadn't been much in the way of funding from our National Science Foundation. In the last couple of years, the NSF has really stepped up with what was called the CCNIE program, and it's now called the CCIE program. And there are a lot of universities who have gotten grants through this to really transform how they do their networking. And this vision statement is very, very well aligned with that funding, where it really encourages universities to look at software-defined networking, to create an abundant bandwidth situation, and to put in a science DMZ to really enable that friction-free science. So I think there's a lot of support for this going forward within the US. Internet2's had a program we called our Innovation Platform Program, which has been very successful in terms of reaching out to campuses. And we've basically asked campuses in our pilot phase, which is now transitioning to just a full program phase, to commit to doing these things, to commit to 100 gig networking, to software-defined networking, and to science DMZs, and do that in a way that the entire ecosystem of universities starts becoming this laboratory for innovation coupled with the backbone networks as well. We've also been partnering with ESnet and Indiana University to put together a series of workshops we call Operating Innovative Networks workshops, or OIN workshops, and if you Google that, you can find the slides and the like on the web. Basically targeted at the lead campus network architect in terms of how to transform your university into an environment that supports innovation like this going forward. So that's one plank of how we've been doing it, is sort of a network transformation. We've also attempted to be an exemplar in the backbone in terms of what we support in this space as well. So what we've been able to say for over a year is that we have a 100 gig testbed for innovation that's available nationwide right now that you can use to do your innovative application development. So let's dig into that a little bit. The first thing I guess to say is, if you look at how you would define the Internet2 network today, it's a 100 gig nationwide backbone. We're rolling out the capability, I'll talk more at length, to create virtual networks across it. It supports data-intensive science. It's interconnected with the public internet, and we've got a year and a half of solid production experience. And it allows you to link to dozens of high-performance compute clusters, campus data centers, SDN ports, et cetera. So the whole thing has really transformed itself over the last 2 years towards this goal of creating an innovation environment. Sorry, this slide isn't very good. Had problems with PowerPoint, and it keeps doing this periodically to me. But basically, this shows the internet network. The one that's on the web, I think, will work a lot better. But the gist of it is basically we have about 10 nodes that are 100 gig routers. We have 30 plus nodes that are 100 gig layer 2 devices. And then we own our own dark fibers network as well. And so, it's about 18,000 route miles that we're able to do this. One of the interesting things that we've done over the last year is, so our entire layer 2 network runs in SDN mode. It's a heterogeneous mix of brocades and junipers, and that's using the OpenFlow 1.0 protocol. What some folks may not realize we did in the last year is our entire layer 3 network is now migrated on top of our layer 2 network. So our entire production layer 3 network now runs over OpenFlow, essentially. And we've had, really no problems with it. It's not been any worse than any other network. In fact, it's given us a lot of flexibility going forward. So if you do a trace route across the Internet2 network, you'll notice all our routers look adjacent to each other because they're actually connected by SDN-enabled layer 2 VLANs. And then this slide, I had the same problem with color-wise, but shows basically all the regionals and campuses that we've connected to as well, and the scope of the connections. So, in terms of creating an exemplar on the backbone for what we're hoping the campuses were doing as well, I think that we can say yes, given the definition, we've achieved the abundant bandwidth, the programmability, and the support for data-intensive science. So then the question is, what comes next? One of the areas we've really focused on is network virtualization, And then a looming area, which I'm not really going to talk about today, is integrating with compute and storage as well. So this is the software stack, and I've been a little high level, so I'm going to go a little low level for the next few slides, that we're currently running across the Internet2 network to support all those features and create that innovation environment. And what we've done is we've taken a mix of code that exists and written some code, but this is entirely open source. So there's nothing in this software stack that you couldn't deploy on your own network today. The core thing is, don't know if I can get that to work or not. Up there where it says OESS and is basically how we implement our layer 2 VLAN service. So it is essentially OESS has the NOx controller inside of it. It speaks to our open flow switches, ignore the flow space firewall piece for the moment, and that allows us to implement a layer 2 VLAN service across our backbone with resiliency and failover to backup VLANs. We implement the interdomain piece. My general philosophy has been if we need to build it, we'll build it, but if we can reuse somebody else's, we'll also do that as well. ESnet's done a great job with Oscars and recently adding the NSI extension, so that's how we do our interdomain piece for our layer 2 VLAN service. But one of the things we wanted to do was we wanted to create the ability to do network virtualization. I suspect that 90% of the network researchers out there are perfectly happy with a layer 2 VLAN between two racks. And they do their experiments in the racks and they just have to link them together. But there are some researchers who say, look, networking should be done totally different. I want to write my own controller and I want a $100 million network to show this out on a national platform. And we want to say yes to that request. And so the way we're doing that is we're trying to create the ability to do virtual networks. And so originally we looked at FlowVisor, which came out of Stanford. Was affiliated with the GENI project. It didn't really scale to our needs and it wasn't really targeted to our use case. So we rewrote rewrote it as flow space firewall, which is essentially a VLAN slicer. So what this enables us to do is to say for our production layer 2 VLAN service, we're going to use VLANs 2,000 to 4,000 across the backbone. And we do VLAN translation at the edge, so it doesn't really matter what range we use. And then, but you know, if Michael wants to write his own controller that says, in the winter we go the southern route, and in the summer we go the winter route, maybe not the best idea, but it's an idea, and I've got a controller that will do that, then I can implement that and basically grab VLAN range 1 to 100 on the Internet2 backbone and at least from your controller's perspective, you'll be directly talking with the switches. Now the reality is flow space firewall is a VLAN slicer and a resource protector, and so when the applications controller thinks it's talking to the switches, it goes through the flow space firewall, and the flow space firewall says, well, were you within the allocated VLAN range? If so, yes, then I'll let it through. But also, you could be doing all sorts of bad things, like you could try to fill up the entire flow table, in which case you would starve some other production services. So it tries to protect resources as well. But the idea is basically, as long as you use a modest number of resources within the range of VLANs that we give you, you can have control of the switches as if you were talking to them directly. And so we demonstrated this February, working in conjunction with ON Lab, which is a spin out from Stanford, where they have their idea for a network operating system, ONOS, and OpenVertex, which is their own multi-tenancy app. We could run that within a slice of our test network, which we're now rolling out on our production network, while simultaneously in another slice, we're also running our production software. So that's basically the vision we have to create a network virtualization environment. And I've got some details here, which I'm not really going to go through, but will be available online, talking through some of the design details of flow space firewall. And if you Google for that, you can download the documentation in the tool. And like I said, it's all open source. These are just some examples. I guess the one other thing is, of course, we're still vetting, in a sense, the quality of our resource protection as well as what the applications do. And so we've instituted what we hope is what we admit is a heavyweight process, and we hope will become lightweight over time, where we sort of work with the application developers to submit what they're going to, from the perspective of flow space firewall, what kind of commands are you going to be giving, how fast are you going to do them, et cetera. And so then we can kind of test that out in the lab on an at-scale separate network, 5-node network that we have, on an in-the-lab network that's the identical switches, and basically verify our resource protection and understand the behavior of the application before we do it. But over time, the intent is to just make it so they can very quickly get on the network in their own slice. This may seem like a lot of work to go to support network researchers, but I do think it's important. But more than that, if you can imagine that we can create an environment in which network researchers today are really having their own space to say, I've got the best idea in networking, let me prove it. If we can create sort of the virtualization mechanisms necessary to allow them to do that, it's only a short hop away towards each class of applications gets its own slice. So you could well imagine that on the Internet2 network in the future, there is a slice that is well tuned for bulk FTP. There's a different slice that's well tuned for video conferencing. And each different pattern of application usage might very well get its own slice going forward in the future. And then we talk a little bit about the types of failure modes we're anticipating and how we're compensating for them. Let me try to wrap this up pretty quick. So I'm trying to say basically that we have a virtualization strategy, and we're still starting to work on how we integrate with compute and storage, but that's really the next pieces that we need to solve going forward to support innovation going forward on the Internet2 network. And we're trying to get these same capabilities pushed down into the campus as well. That's in large part why we're doing this open source approach. We're also working very hard and insisting on the vendors that we only want to do things in a standards compliant open way. Most vendors you talk to will very quickly say, but oh wait, I've got my own special controller. Oh wait, I've got these little extensions that will make it much better. But if you think about the end-to-end path that most of us care about, you know, the end-to-end path between a US university and a European network is probably European university is about 7 networks. Within the US, it's 5 networks. The chances are that those 5 or those 7 networks have all bought the identical hardware from the same vendor are non-existent. So within the R&E community, by definition, our networks are heterogeneous. That's why when we did the Internet2 network, we deliberately said we're going to have a heterogeneous mix of vendors to force interoperability and to force standards-based approaches. And that's really what we're trying to do here as well. So if it didn't exist, we built it. If it did exist, we either modified it or just took it. And then all using open source tools to kind of create this software stack. And I think it's important as a community that we maintain that stance to the vendors, because otherwise they will pick us off one by one with all their proprietary extensions that seem great within your network but don't really create a community fabric for, you know, our globally connected scientists. Now let me talk a little bit about the Innovative Application Awards. So this is an idea we had last spring. We pulled it together very quickly thanks to sponsorship from Juniper and Sienna and Brocade. And the idea was to sort of kickstart the types of applications that could run across this type of platform. And many of the things that I was talking about we didn't quite have in place yet, so we were using test networks and the like to do it. But the idea was to start nurturing this environment and figure out what we needed to offer in our production services. So the goal for the program was the development of next generation open source applications, general interest to the R&E community that take advantage of the SDN enabled capabilities. And we targeted our call at facilitating data movement and data intensive science applications. But the response we got was all over the map, which actually was a good thing because we got to see more of a variety and breadth of things that you could do. And these are, you know, code that's written by grad students and, you know, is example code, but all this code is available on repositories and open source. That was a contingency of the award. And so basically, we announced the program in May, we asked for proposals in June, we notified people in late June, we gave them till October to do the development, and then we did our first demonstrations in November, we made the applications available in December, and then we did follow-on talks at the Internet2 spring meeting in April. So that's sort of the timeline. It wasn't a lot of money. It was aimed at undergraduate and graduate students at US-based colleges, although we ended up making it, we had another school from Canada as well that participated. And we basically said it's a $10,000 award. There's no overhead, there's no nothing. This was not targeted like in a formal way, like a professor going for a grant. This was targeted at a grad student who'd written some code and wanted to pay for a semester's tuition. So we gave them $2,000 for getting their proposal accepted and $8,000 when they submitted a completed working project. And they were individual awards. And so it was really targeted at a different niche than our National Science Foundation would go after. We ended up picking 8 projects. They were all project teams. I think all but one of them were project teams. Mix of graduate, undergraduate, and university staff. Most had an advisor. And they targeted a variety of things from data movement to network management software to security. All the projects are completed, as I said, and we've got the code out there. There are slide presentations you can find if you go to the ESnet Global Summit, and you can walk through them. And I'm not going to go through them in depth. I'll just skip through them lightly, and you can look at them if you're interested. From North Carolina, we had a project to do network administration control. That would basically, the example was a visiting physics professor could have their identity and device recognized and immediately routed onto their institution's dedicated physics network back home, even though they were in a remote school. Open Vertex I talked about briefly before as the example that we showed at ONS, but this is basically a multi-tenancy solution, not unlike Flow Space Firewall, but written with different design goals in mind, and it's a different successor to FlowVisor. And this should be an important point, is just because we built our software stack in one way doesn't mean we won't evolve it over time. That's the way the best open source software works, is if somebody comes along and builds a better piece in that stack, we'll replace it. And this is sort of the demo. I just thought it was kind of cool that the ON Lab guys did. So this is the Open Vertex one, and then here's how they were showing using this. If you look at the outline of the network, you'll recognize that roughly corresponds to part of the ESnet2 network. They built a virtual network. They created virtual links where we didn't give them one, and they showed basically the idea that many different servers could be rerouting on the fly. It's a nice demo. University of Illinois, they did black box congestion control. At Georgia Tech, they had 2 projects at Georgia Tech. One was focused on efficient video streaming, which was a really nice project. University of Florida did ELF, network enhanced data prefetching. Then ON Lab did another one on seamless interworking of software-defined networks and IP. This is a really nice project that sort of showed how you might do a routerless network, basically IP over SDN. There was another one from Georgia Tech on software-defined exchange points. And there was another one from University of Victoria around the GENI experiment engine infrastructure. And so our little contest generated a whole lot of different ideas, gave a little bit of kickstart money to get a grad student moving along on their project. And the idea is that efforts like this and efforts to create an innovation platform lead to the creation of new companies, like I showed in that early slide showing what came out of the 90s. And that's what we're hoping to do next. And that's it for me. Hopefully not too far over.
Thank you, Eric.
Yep.
So my plan was to have a common Q&A session at the end with the last 10 minutes. But if there are any pressing questions for Eric now, feel free to ask 1 or 2 questions max. But I'd like to leave the bulk of the questions to the end, though. So any immediate questions? No? Oh, yes. Go ahead.
Yeah, we haven't decided on that. The contest was pretty successful. It was a lot of work to administer. We basically wanted to get a little farther along in terms of rolling out the full innovation environment, and then we'll probably look at it again next year. And the question was, how would we announce future ones? We sent it out to pretty much all the ESnet2 mailing lists. I'd be happy to share it with the Terrain community as well and get that broadcast out onto your, the general mailing list as well. Our intent really is to solicit contributions from around the globe, and we'd be interested in doing that again.
Thank you.
Yep.
Thanks, Eric.
Thank you.
So next up we have a pair of speakers, and this is for the Enlighten Your Research initiative, which is a more global initiative to support innovation, an innovation program. Ed and Mary Hester will explain this to you in more detail. Just a couple of words about the 2 speakers. Mary, she is a relatively recent addition to our international team of collaborators, I guess. She works at ESnet as Science Engagement Coordinator. Ed has been around a little longer. Some of you might know him more because he's been around a little longer. One interesting fact about him is he's a life logger, and he carries this little device on his jacket that seems to record everybody he sees, everybody he says, everything he says, everything that you say to him as well, apparently, is recorded on that. So, anyway, without further ado, if you'd like to start on your presentation.
Yeah, thank you, Roberto. So I don't want anyone to feel like we're being sorry, is that me? Sorry, apologies for that. I don't want anyone to feel like they're being inundated by Internet2 speakers today, but it's purely a coincidence, really, that Eric and I are going back to back. I'm, in fact, not wearing my Internet2 hat during this presentation. Rather, I'm speaking on behalf of a collaborative effort called EYR-Global. But it's actually a brilliant transition, Eric, from the Innovation Application Awards into EYR-Global, because essentially EYR-Global is, although we hesitate to call it a contest, it's a program that reaches out to researchers on a global scale and provides them with targeted and direct research support from the NRENs. And I'll talk a little bit about the outreach efforts, some of the challenges, and then Mary will go into some more details about the selected projects and some of the lessons learned. So if we have been doing our jobs properly and our outreach efforts properly, this won't be the first time that you've heard of EYR-Global. We've actually were at Terena at TNC last year. We were at the last two Internet2 meetings, and we were at Supercomputing this past fall, where we announced the selected projects, and we did a similar presentation at the Internet2 Global Summit last month. So if you haven't heard of us already, that's sort of our fault. But if that is the case, we do have, let's see, do I have to point this at anything in particular? Okay. So again, these are just sort of a table of contents for the presentation. I'll go over the program, the structures and goals, and some of the outreach efforts. And then again, Mary will go into some of the proposals. So what is EYR-Global? About 18 months ago, our colleagues at SURFnet approached Internet2 and asked us if we were interested in considering expanding the Enlighten Your Research contest. That was sort of a domestic contest in the Netherlands. If we were interested in expanding that on a global scale. And we said certainly we were, but we thought we needed more partners than just the US and the Netherlands. So we took a few months and developed this sort of skeleton for a program, reached out in the US to ESnet and to some of our other partners in the European space, and ended up with 5 NRENs. You see here GENI from the UK and Funet from Finland offered to be a part of the project as well. You see also that it's called EYR-Global, but on the map it's clearly not global. It's really just North America and Europe. And that's one of the things that we're here to address. So again, we want to give you a little sense of what the program is about, but ultimately we're here to let you know how your organization and or your researchers can be a part of EYR as we expand the program and do a second iteration of EYR-Global next year. So you see here the mission of EYR-Global is to identify collaborative projects that could essentially benefit from and impact from high-performance networks. It says here any country. I think in the U.S., I don't think we can quite live up to any country, but most countries I think we could probably support in any research domain. The selected collaborations receive network services. again, targeted network services to help facilitate their research. And so why are we doing this? We've heard many talks already this week about the changing nature of research and education, how globalization is changing everything that we do. Data requirements, of course, are increasing. NRENs are critical in the environment to support R&E. And we don't really have the experience collaborating globally that's required to support these changes. And so EYR in some ways is designed to address that. It's sort of an experiment on how we can the NRENs can work better and more efficiently together. In some ways, however, these are things that we already knew. It's really nothing new, and in fact, if these research projects had come to us, we would have been in some ways obligated to support them. And so what is the value, when we think about why we put this together, what's the value to the NRENs? And I'll skip that slide and go back to it. So what's the value of coming together? In some ways, it's really a PR experiment. How can we use outreach to bridge communication gaps between the researchers in the US, between the researchers and the CIOs, between the CIOs and the NRENs, and now we're learning between the NRENs themselves. So it was just a targeted devotion of resources to address these needs. And again, provides valuable coordination for future efforts which we know are coming. We'll go back. And so what do the researchers get? There's no, unlike the Innovation Apps program in Internet2, there's no direct financial reward. We're not giving out money to any of the selected projects. Instead, again, we're giving target 1 year, essentially 1 year. We're not really sure. I mean, it'll differ for each one of the selected projects, exactly how long the support will last. But it's a targeted consultation and then a year of targeted support for their specific projects. And then again, the research projects, they're not here with us today, but at the Internet2 meeting, we had each one of the proposers speak and give them an opportunity to give a little bit of exposure to their specific projects. So just a little overview of the program itself. It's a two-phase program. As I said, it was about 18 months ago that SURFnet approached Internet2 about potentially doing this. And it took us a year and a half to get to the implementation phase. We're learning that global collaboration is not easy. It takes time. Interesting to see Eric's slide that says the announcement of the Innovation Apps was May 2013, and in December, they had everything finished and all the projects were submitted. Not quite that easy on the global scale. Working across NRENs, there's a lot of different policy challenges, a lot of legal issues, not to mention connectivity challenges. So it obviously takes a little bit longer. We got through the application phase with a number of different proposals, and I'll get to that in a second. After that first round of submissions, there was a targeted consultation phase where NREN engineers took on each one of the submissions, reviewed the proposals for clarity and really for seriousness, and pushed those into what we call the second round, which was another consultation phase, and ultimately to the CEOs of each of the participating organizations who together made the final decision on which projects will be selected. We're now into the implementation phase, and there's still a lot of question marks here. We're making a lot of progress, some more than others, but we've got engineers assigned to each one of the projects, and they're working through getting each layer connected. And we're going to put all this together in a final report, lessons learned, and report back to the community on our progress and success. So as I said, this is really just a PR effort for the NRENs. And so a big part of that is the targeted outreach. And so it was a combination of project managers from each NREN, communication specialists, PR folks, and network engineers all came together for a targeted and global outreach effort. It included, as you see here, social media, websites, email lists. Again, we've been at all of the major meetings trying to not only get the word out about the program, but to get more of you interested in being a part of this. So I'll go back to this one. So just a little, some statistics on our success in the first round. 27 institutions around the world were involved in proposals from 8 countries and a variety of different academic fields. And then back to the map, you can see it sort of maps pretty well to the NRENs that were involved. And so we hope that that holds as we bring in NREN partners from other areas. We'll hopefully see some more challenging proposals come from a greater number of countries. And on to the selected projects. So there were 4 total, 1 from bioinformatics, 2 from climate, and 1 from biophysics and neuroscience. And with that, I'll hand it over to Mary, who will give you a slight overview of all of the projects and then talk a little bit about the lessons learned.
All right, thanks Edward, and thanks Roberto for the introduction. I'm Mary. I'm relatively new at ESnet, but like Edward said, we're representing our collaborators here today. We just happen to all be from the United States today. So anyway, I'll go ahead and jump right in with the first project. So there were 4 proposals that were accepted altogether. This is the cross-site virtual machine operation, and it's led by David Van Enkvoort. This project provides 1 gigabit light paths between 4 different sites in the Netherlands, Finland, and the UK. It's all connected in a mesh topology. The current status of this project is that we're working on getting static circuits up and configured in the mesh topology, and then we'll take it to the next step from there. The next project is the International Networking for Climate proposal. This is led by Dean Williams in Lawrence Livermore National Lab. That's located not too far from where we're stationed at ESnet. So we're working on getting 5 international data replication sites up to 8 gigabits per second. And that actually reaches between Australia, the Netherlands, the UK, Germany, and I think I'm forgetting one. But yeah, and the US, of course. So we currently have perf-sonar nodes set up at all of those sites, or 3 out of the 5 are set up. The other 2 are coming online, and we have the network bandwidth upgrades ready at the relevant sites. So moving on to the next project, an advanced distributed computing approach to high-resolution climate modeling. This is the second climate project led by Henk Dijkstra from the Netherlands as well. And they are actually doing some research on climate simulations, and they're trying to figure out how ocean currents affect climate change. And so they're going to be running a simulation across 4 different supercomputers in different countries, and they're going to be using the ANA link to run these tests. And they're actually going to start the test runs for the simulation throughout June, and they'll be running that for 8 to 12 hours per day, Monday through Friday, and then they're hopefully will be performing their research in the fall. And then the last proposal that we have is achieving multidisciplinary high-throughput quantitative behavior analysis and advanced computing and networking tools. This is the Neurosciences and Biophysics project led by Stephen Helms from AMOLF. So they are looking for increased international connectivity between their laboratories in the US, Japan, and the Netherlands. So they are looking for a 1 gigabit light path between or via the ACE link. So we're setting that up. The Netherlands has their link configured, and they're working on the US one. All right, and then just a quick overview of the network topologies that we're working with. As you can see, they vary from site to site quite a bit, varying architectures and infrastructures that we're working with to do the networking. And then I'll move on quickly to the lessons learned from this program, which is, it's really been a great experience working with everyone across all time zones. So the collaborations, what we've learned is that, you know, the collaborations with the other NRENs is obviously increasingly important as science and research in general gets more international. And then it's also essential that we have our commitments from our NREN partners. So we usually have a PR specialist or a communications person and a network engineer that helps. Of course, the initial engagement for any new program is time consuming, but we know that that will become easier with the next round. And then another fact is, you know, changing the mindsets of our researchers, you know, to use the networks it is hard, but it's not impossible to do, and that's something we want to continue to support throughout the next program. And something that was interesting that we really found out is the researchers themselves find it more valuable to have the network expertise and the help come out of this program as the award, as opposed to any sort of monetary or like hardware allocation or something like that. And then we also have a better understanding of our different research needs. And it's actually also very interesting that we're seeing all these different needs across, you know, the international countries. Sometimes we're in the same boat depending on the different science domains. And sometimes the needs are different. And, you know, another great thing that we had come out of this is we have a stronger engagement between the networks and the research community, so we're really trying to build that relationship. And in closing, you know, we do know that more partners equals more opportunity, and we can get a stronger impact with this program if we all work together as a team. So looking forward to the next program, we are looking to run the program biannually. So every other year. We started it in 2013, and we're hoping to kick it up again in 2015. It's certainly a very valuable exercise for us to pursue. And you know, we're looking to add more NREN partners the next time around and continue to increase the network exposure overall to the researchers, and continue to build stronger relationships with the NREN's researchers and usually the people at the local sites. So great. I think that's it. Oh, and we also want to give a shout out to our affiliate partners at DFN, ARNet, GEANT, and RNP. So they're all working with us to help these projects get up and running. So thank you very much to them. All right.
Thank you, Mary. And Ed? Are there any immediate questions for Mary and Ed? Nope. Oh no, there is one. Mauro.
Thank you. I think it's a very interesting thing. My main issue is that if you scale this type of activity to a larger amount of NRNs, wouldn't be that substituting to official bodies like NSF and the EC in funding this type of activity and deciding the research? I mean, I see an issue in scaling, in starting to collide with what are the EC priorities or NSF priorities, and then the need to justify what you're doing. Or do you have maybe a different view on that?
So, you know, that's something we certainly thought about. You know, is at what level, you know, does it get sort of too heavy and too burdensome, you know, and too costly, You know, I mean, it's not, although we're not giving any money to the projects, it costs us, you know, a lot in staff time and resources. And you know, we ran into a few proposals that we couldn't support because they, you know, the connectivity was going to cost one of the NRENs and not one of the others. And so we have certainly thought about whether or not, at least in the U.S., we've thought about, you know, what kind of funding might be available for something like this. Certainly in the U.S., there's funding opportunities to do this type of research support domestically. And so it would be interesting to think about, you know, who we might talk to about, you know, getting some financial support to do this on a global scale. Because as you say, at some point, it's going to be burdensome.
No, thanks, because this is exactly, on purpose I didn't raise the issue of cost.
Right.
But indeed,
as did we, yeah.
I mean, at least in the EC, but also in the United States, there are a lot of funded projects by the official organization that would love to use such kind of infrastructure because it fits perfectly with their environment. So I was thinking, shouldn't we look for let's say, half and a half, in the sense that half is something we support officially, but the other half comes from supported projects by the NSF or the EC, and so that would be funded projects, and also they may also contribute to the indeed cost of these infrastructure. Yeah. Thanks a lot.
Yeah, exactly. Okay, thanks for that. So we'll go on to our last contribution. So I welcome Michael Enrico, who's CTO at Dante, and his bio is on the web, but some facts which are not out there on the web are that he is a very active scout leader and has also 2 Guinness World Records to his name, or partly to his name. One is the provision of, the fastest provision of long-haul connectivity, which was done recently jointly with Funet, and one goes back more in time, about 20 years ago.
A long time ago.
About reaching the lowest temperature with fluid helium, is it?
So this is back in my physicist days, because I'm a physicist by training. Anyone wants to know more about that and a funny story about it, come and talk to me after. Yeah.
So anyway, Michael's here to talk about the GEANT Open calls, and up to you.
Okay, thank you very much, Roberto. So here's something very similar to what you've heard this afternoon, but this is now the sort of European slant on this. So what I'm talking about here is the Open Call program that's running as part of the current incarnation of GEANT. As Roberto said, I'm the CTO at Dante, and I'm presenting this afternoon, obviously, but there is a large team of others behind this, and I really want to acknowledge them, as many of them as I can, throughout this presentation, but most notable is the name you see up on the screen. There's Annabelle Grant, who were a colleague of Roberto's from the business development team in Dante. She's put a great deal of effort into making this work, because open calls are nothing new to many people who are familiar with working in EC-funded projects, but they are certainly very new to the GEANT project. So we've taken a slightly different approach to this as well, as I will try to illustrate them as I go through. So here's a brief agenda on what I shall talk about here. So first of all, why do we do open calls, and I'll try and illustrate what kind of value we think they bring to the GEANT project. I'll tell you a little bit about how we did and what we did and what were the outcomes. Then I'll talk a little bit more, and we put quite a lot of effort into this, into integrating the open call projects that we've ended up funding into the GEANT program for the mutual benefit of everybody involved. And then finally a few words about the future, and obviously that means the next open call. Okay, so a bit of background here. Like I said, open calls are familiar to many who are on the receiving end of EC grants. So programs like the Future Internet program, many projects there have run open calls. It's essentially a process under which you bring in new partners into your project, and certainly in the Future Internet ones, it's been about bringing in new partners and perhaps bringing in infrastructures. What we have done is try to do 3 things essentially with our open call. So they are to bring in new blood essentially, as you see here, bringing in new partners. We've also done another two things. We've tried to solicit use of some of the infrastructure we have available in the network, testbed style infrastructure, and I'll talk a bit more about that later. We've also done a bit of outsourcing as well. So in essence, as you can see here, this was a stipulation made by the Commission as a kind of this was a condition of the latest grant, essentially, that 50% of the research and technology development effort would be done through joint research, and that means 50% of the work that would normally be done under what we call a joint research activity in the project. As I said, it's partly about leveraging talent outside of the traditional GEANT NREN community, so that means people from universities and also, hopefully, from industry. The intention was to fund a set of 18-month projects starting in October last year, and to give you some idea of the kind of budget against each of those projects, we're talking about it between 100 and 350,000 euros. So what did we do? As I said before, 50% of our R&D spend had to be done through this process. We wanted to bring in new partners, but it was also we obviously had to follow EC guidelines in how we went about selecting projects and how we administer them. So effectively, what we needed to have was a very efficient and effective framework through which we solicited bids, did evaluation, and integrated those projects into the greater GEANT community. The idea being that there are some tangible, lasting benefits to those on the receiving end of the funding and to the project in terms of it getting some useful outputs from all of that. It was also quite important that this framework was open and transparent because we took a slightly different approach to open calls, in so much as NREN partners who were already part of the GEANT project were eligible to apply for these open calls, which is slightly unusual compared to some of the other open calls that have gone on under the umbrella of Framework Programme 7. Okay, so integration is very important, but I'll come back to that later. So essentially, what we did was when we sat down at the beginning of the current virtual, we're in the GN3 plus phase of the GEANT project, which essentially started last April. And when we first, straight away, we started to plan this open call. And in essence, there was a lot of discussion within the GEANT project partners, and what we came up with was a set of 3 themes and then a whole load of topics within those themes. So the first of those themes was to, as I've already indicated, was to solicit users of facilities we have available as part of the GEANT project, and this includes a dark fibre testbed facility, a software-defined networking open-flow facility, we were soliciting users of the bandwidth on demand service that we have, and we were also soliciting bids for an optical terabit demonstrator, again to make use of the dark fibre we have available, some spare dark fibres we have available in the network. So that was the theme 1. Then there was theme 2, and this was essentially a kind of outsourcing, if you like. So this was closely affiliated with the 3 research areas, the joint research activities within the project in those broad areas: network architecture, technology testing, and identity and trust. And as you can see, a whole load of topics were listed there, and so this went into the call text. So the projects that came in under that particular theme were then expected to be very closely integrated with the relevant JRAs, and I'll try to indicate how we've done that later on. And then we had a third area, which was a kind of a wild card, really. So this was where bidders were free to come up with more or less anything, and we did put a few sort of stipulations there. That whatever they bid had to be relevant to the research and education networking community. We gave a few guidelines, but we tried to keep it as open as possible. Okay, so in the end, across those themes, we were actually well oversubscribed in terms of the number of bids we had. I think we had something like 70 proposals coming in, and we were oversubscribed against the budget we had available by about a factor of just over 3 to 1. So, right, so I indicated earlier on that we needed to make sure we had a very robust and an impartial evaluation process. So in essence, what we did there was we followed a process that the Commission essentially recommends. We had our 70 proposals, and as I said, this was amounting to about 14 million euros of costs, when we had a little bit less than a third of that to actually spend. So essentially, we then recruited a small army of external experts to do the evaluation, a little bit like the European Commission does when they evaluate larger EC-funded projects. Essentially, two of those experts were assigned to each of the proposals. They went away. They read those proposals. They met up and came up with an evaluation report. In some cases where the two evaluators had diametrically opposed opinions about a particular proposal, then we brought in a third, and then expected them to come up with a consensus report. So then, having done all that, and that took quite some time, as you can imagine, we had a 2-day panel meeting with a select group of those evaluators and people from within the project and people from the EC. And the point there was to do a kind of levelling and make sure that there was a consistency across the evaluations, and make sure that all of the language used in the feedback statements was appropriate, and just generally make sure that the whole evaluation process looked fair. So, as I said, evaluation by external experts. They produced their consensus reports. We had our panel meeting. So what were the results? So if we look at those 3 themes I mentioned, which are using GEON facilities, the joint research work, and the innovation, then those are the statistics of the funded projects against those 3 areas. So you can see just over half ended up being joint research work type outsourcing, if you like. Just around about a third using GEON facilities, and 15% against the innovation topic in the end. That was about, I think we funded 5 proposals actually that represent that innovation topic. Here's some information about the new parties, if you like, the new organisations that were the beneficiaries of the awards. So there's a whole long list there. You can see there's a lot of universities. This is all of the universities and research centres. Some of these parties were previously third parties in the GEON project. So after this, they then became full partners in the GEON project, because there's something I've not mentioned so far, is that the new beneficiaries all became full project partners. That was actually quite difficult to bring them in. In actual fact, I think in the Framework Programme 7, many projects have kind of had to work hard to get the contract sorted out and so on to bring these new partners into an existing project. And it will be made a bit easier, by the way, in the next round of the Horizon 2020 programme. So those are the R&D centres and universities that were amongst the winners. There were some of the NRENs that, like I said before, some of the NRENs themselves could be part of the mini consortia that applied to these, that made some bids, and those were the ones that had proposals that were accepted into this process. And finally, there were a few commercial entities, and you can see them listed here: Telefonica and Spain. That picture there, by the way, is Telefonica Towers, as I call it, Telefonica HQ just outside Madrid. And some other SMEs there, CreateNet, NextWorks. SurfSara is not really, SurfSara probably is not really a commercial organisation in any way. I mean, it's related to the Surf Foundation. But, anyway, and a company called InnoValor. So a few stats. So we essentially had a total budget of €4.5 million. Of that 4.5 million, the contribution coming from the EC is 3.3, so the rest is made up by the partners putting together the bids. 21 projects ended up being funded, a total of 439 man-months of effort, 37 beneficiaries amongst that lot, and this brought in 32 new partners. So same stats there. Oh, I don't know if I've got the same slide here. Apologies for that. Okay, so now a few words about integration. So this is quite an important part of what we did here. And there's two elements to this. There's an administrative integration and a technical integration. So to make that work as efficiently as possible, my colleagues, Annabella mentioned her earlier on, and some of her colleagues back in Dante, worked hard on negotiating all the contractual elements, on bringing, for example, we brought all the projects to the last of the GEANT 3, the GN3 plus, the symposium we held last, actually it was the GN3 symposium, but we brought them into that end of last year, and made space available on the GEANT intranet, given them some public-facing and some intranet-facing space, and essentially welcomed them into the GEANT project, and tried to make that as a smooth a process as possible. So we have information in the public part of the GEANT web pages, and you can find all the open calls there. But for those of you that are in the GEANT project, there's more information under the intranet, which shows which shows a lot more details. It shows things like RAG reports. It shows the deliverables that they have to deliver. On a quick note on deliverables, when the proposals came in, we saw that a lot of them were very, very much like the kind of proposals that the EC would normally see. They had long lists of formal deliverables, but we took a sort of very different approach to this and said, no, we don't really want long lists of formal deliverables because you've only got 18 months here. We don't want you spending all your time writing as many centimetres of report as you can. So we said, essentially, each project only really has to produce one formal deliverable, as in a final report, and then in between that, they have a set of milestones. So we made sure during the negotiation process that we set a set of milestones. I mean, so very often there's a small report, written report against them, but we've not tried to formalise that too much. So they can actually get on with the work in hand. So that's a bit about the administrative integration. Here, by the way, is a screenshot from the intranet pages for one of the projects. So down here, for example, are various milestones, and it's all accessible to. This is not publicly accessible. This is accessible to GEANT project partners. But like I said, there is some public-facing material in less detail. So then I'm going to talk a little bit more about the technical coordination now. And so we put quite a lot of effort into this. So what we've done here is we've created a new role in the GN3 Plus project. We call these technical coordinators. So each project has a technical coordinator assigned to it. These are subject area experts drawn from within the original GEANT project community. So they can be, for example, task leaders or people assigned by task leaders within the project. They act as a single point of contact, and essentially they provide feedback to the project, and they try to integrate the results back into the GN3 Plus project itself. As I said, we use the existing activity leader structure to do this. And these technical coordinators, by the way, they meet quite regularly under the chairmanship of either myself or my colleague Guy Roberts from Dante, depending on who's available. So they do other things as well. They do things like they monitor the spend, they monitor manpower use, they make sure that VAG reports are there on time, and then keep an eye on them to see what they're producing, to see how effective what they're producing is fitting into the GEANT program itself. So there are 11 of these coordinators, and what I'm just going to show you here now is the fact that we've divided up these projects into a number of technical areas. So here they are. they are, just build this slide. So the 4 areas are network architecture and optical projects, and there's 5 in there. There's 6 that are related to software-defined networking in various forms, 6 that are related to authentication and authorization technologies, and then 4 which we call applications and tools. And then the parts of the GEANT research program that they are affiliated to are shown in the green blocks on the sides here. And so those of you that have been listening to some of the talks here during TNC will be familiar with many of the activity leaders that lead these various activities within the GEANT project. By and large, these are the joint research activities. I mean, clouds here is a service activity. Application services is SA, one of the service activities, and test beds is another service activity in the current project. So there are plenty of talks on those topics. But as I'll show shortly as well, there are plenty of talks throughout the TNC on these open call projects as well. In fact, you've missed a few already. So I think now I'll just go through them and select a few. So under the banner of applications and tools, there are these 4 projects here. I can't really talk about all of them in great detail, but the 2 I've highlighted here in yellow are being presented or have already been presented here at TNC. So ARES is an interesting one about advanced content delivery network for the purpose of delivering genomic data. So there was a talk yesterday about that from Gianluca Viali from the University of Perugia. So we've got a couple, so the other projects you see here are a video on demand distribution service project. This is Lancaster University behind that. E-music is about using dynamic circuits to support remote collaboration in musical education and e-culture. And then the other one, which is highlighted in yellow, is NSI contest. So this is about building an NSI conformance test suite. And there's a talk on that tomorrow in session 10B. Next batch, so the authentication ones. So there's 6 of projects here, and no less than 4 of them are being presented here at TNC. So again, those are the ones in yellow. So GEANT Trust Broker, I'm afraid you missed that. That was yesterday in session 2B. MEAL, this is about EduRoam across 4G, across LTE networks. It's quite an ambitious one between Janet and SURFnet. It'd be interesting to see how that one pans out. So you can find out about that tomorrow in session 10A. Sense, so you'll find out about that one tomorrow in session 10A. That will probably be Stefan Winter presenting that one, I think. And then finally, What for Lower, about a web of trust type application. So that's going to be again tomorrow in session 10B. So it looks like you'll have to choose between those 2, unless you rush from one room to another. Then there's the network architecture and optical projects. So here are listed 5 of them. So out of these, the one which you can hear about or today, actually I'm afraid you can't hear about it now because it's actually right now in session 5B. So that's on, it's unfortunate really that I didn't do this talk before all of these guys were talking, and that's the way of the timetabling. So that one is about the recursive internetwork architecture arena and trying to promote it as a technology that could potentially one day be used in the NREN community. Just a few words about some of the other ones here, because these projects, certainly the top 2, Coffee and ICOF, they're the 2 that are making use of some of the spare dark fibre we had left over from our transmission network migration of a couple of years ago. This is where we have, like I said, we have some spare fibres going across for example, between London and Paris. That's going to be used by the ICOF project. The ICOF project is about clock comparison over optical fibre. This is the metrology, the frequency metrology application And then if any of you were in the talk given by David Salmon earlier on, then he touched on some of this. So one of the partners in that project is NPL, the National Physical Laboratory in the UK. Coffee is another optical project, and they are so that fulfills the terabit trial theme we had earlier, or topic we had listed earlier on. So that's being done by Mario, to remind me of the name of the organisation in Italy that are doing coffee.
It's a university.
It's CNIT, isn't it? Yeah.
Scuola Sant'Anna.
That's it. So it's a sort of virtual organisation of universities that are involved in telecoms and networking research. So they're doing that. And they should be using, again, some spare fibre in the network, probably the route between Milan and Vienna, or at least halfway towards Vienna. So there's a couple of, there's as you can see, there's another project there on a multi-domain optical modelling tool, and Reaction is all about the control of flexi-grid optical networks. So the fourth area here is software-defined networking. So all of these projects are, by and large, using the open flow facilities we have available in the GEANT project. That means to say what we call the GOF, the GEANT Open Flow Facility, which exists today, and in the future they will probably be using the Testbed as a Service, or TAS, which you can hear about. Actually, there's a BOF about testbeds after today's this evening, after the last session of today. So the one you can hear about, unfortunately, again, is right now. It's COCO. So this is about a community connection service, on-demand community connection service based on using OpenFlow. And other projects here. DINPAC, for example, is about quality of service using OpenFlow. Dreamer is about NREN style services, again, in a software-defined networking context. Moat is about extending network markup language to accommodate OpenFlow-enabled technologies. So that's those are the various topics. Quick run through them. So what are the next steps? Okay, so obviously we're monitoring the delivery of the projects, and then obviously time will tell. We've got some idea already of which projects are delivering slightly better than others, but by and large they're pretty successful. We're quite happy with what's going on within the projects. But come the end of the project, of course, we will have a good view on which were good and which were bad. So then we will do some evaluation at the end of that period, and we'll look at what worked well, what didn't, and then we'll start preparing our strategy for the next open call, for open call number 2, which will be part of the GN4 project when that starts up. So we would expect to do that, by the way, to launch the next open call, probably not until around about September 2015. And then expect the projects to start funding the projects around about April 2016. So the expectation is that the new funding regime and the Horizon 2020 element, you don't have to bring new partners in as full project partners, but they can come in as third parties. Then that will we expect this open call 2 to be very popular. So, in summary. So we've conducted an EC compliant open call process. We think we've done it successfully. 21 projects started in October last year. They're all mostly making good progress. We've put together a very strong management framework to make sure that they keep on target, and that we integrate as well as possible the results coming out of those projects. Obviously, we won't be able to integrate all of them, and some of them are a little bit more blue skies than other elements. So we're focusing on delivery. So we're doing close monitoring, and as I said, working hard on technical integration. And with that, I shall finish asking questions.
Thanks, Michael. So at this point we can open also the questions for Michael and questions in general for the three talks that we had today. So floor is over. Anybody like to ask?
A question for Eric. You described the OpenFlow architecture and the deploying user-defined network capabilities across Internet2, but you rightly said that, of course, it's no use unless it also flows into the campus. So can you elaborate a little bit on what you're doing to persuade campuses to do this, what they're actually doing, whether any are doing, what kind of pressure can you put on or research you put on? What is the status of that whole area?
Sure. So I think there's a bunch of combined pressures. Internet2 attempted to define sort of expectations for leading campuses. Those were the three pillars that I talked about: the abundant bandwidth, the friction-free science through science DMZs, and opening up the network stack through SDN. And then we had a pilot program where we reached out to those campuses and said, if you are a premier leading research university, you would want to be an innovation campus. And here's what we'd like you to do, and we'd like you to commit to 2 out of 3, with doing the third one a year after you do the first 2. And that had surprisingly good results. A large part of why that probably had good results was concurrent with that, a little bit more fortuitous than anything else, was this CNIE program launched by the NSF that said, if you'd like $500,000, you commit to those 3 things, and then you can go off and buy some equipment. And it depended on which what the campus needed and what they did. So it's not perfect. It's not 100% across the board. But we have found that a bunch of campuses are willing to do precisely that. Then the third thing that we did was we need to run our network in a way that works well for us, but we also tried to do it in a way that would benefit our campuses. And so we made some very deliberate choices around open standards, about using open source code, that the campuses could really take everything that we had done and put it together. And probably the final thing I should mention is then we added, because a lot of this was new to a lot of campuses, they hadn't really thought about network architecture in a while. Compared to where we were in the 90s, the importance of the network on the horizon of the CIO has probably gone down. That's old solved problem, that I've delegated as opposed to being front and center for the CIO at a campus. And in some sense, this elevated that back up. And we said, no, networks aren't done. There's a lot of transformation that can happen. And so I think it's kind of the common, and then we said, we put together these workshops with the ESnet and Indiana University to really, send your best network architect on your campus to there, and we'll give them a bunch of new ideas of things that you should be doing. Because over time, what's happened is you really have drifted into supporting students on their laptops and cell phones, as opposed to thinking about how are we enabling science for the best researchers that we've paid to bring to our campus. And so I think it's a combination of those things. I'm not saying that's an exhaustive list or that will work in every instance, but it seems to be having a good effect.
Any further questions? Yes, up there.
Thank you. This question is for Michael. I'm wondering if the NRENs outside of the EU are eligible to participate in any open calls, either as
yeah. So the answer to that question is any entity any legal entity which is eligible for EC funding can apply. Now the answer to that, of course, it varies. I'm afraid it depends. For example, it can depend on what kind of what sort of, how can I put it, what sort of diplomatic kind of arrangements are going on between the EC and some part of the world at the time. But obviously it's all those in Europe and other parts of the world as are current at that time, I think. Maro's got a comment, I think, as well on this, I suspect.
Yeah, to be more precise, each call text has appendixes which list exactly the associate partners, the partners who can collaborate but can't get funding. So the EC is very elaborate on these kind of things. Usually, by heart, I think that large amount of countries can participate. United States can participate but not get funds,
funding,
of course.
Yeah.
They are too rich, for the European Commission at least. My question is slightly a different one. I understand the need for innovation and supporting the scientists. What they can't do on the network we have now. I mean,
So
I'm trying to see the other side of the coin. If you want, I fully understand we need to advance because that's fundamental. We need to find new technologies. But what is the feedback from your users on what they can't do? And so what are the hot areas in which we have to put more effort?
So I'll start with that. So I think there's two parts to the answer. One is we don't know. And I'm not trying to be flip by saying that, but you know, in the 90s, if you were in the U.S. and you'd gone to your AT&T sales rep, and you'd said, "But I don't want 56K. I want something much better. I want a gig." They would have said, "Why? You can read your email perfectly fine. You know what? You don't need images in your email, and I don't know what this web thing is, right? I mean, you know, so the incumbents always have, particularly the commercial incumbents, have a vested interest in selling you what they have to sell today. And so a large part of what we're trying to do is create an opportunity for a new idea to emerge that wasn't driven by a requirement, but basically came out of an abundance or a friction freeness or whatever it might be. That said, for me at least, I think, and others will have different opinions, one of the things I guess I've heard is that there was a sense amongst researchers and developers that our ecosystem had really moved towards a black box phase, right? That you basically had these black boxes coming out of the router vendors that supported all sorts of legacy protocols you might not care about anymore. But it was very hard to add anything new, incredibly time-consuming, long standards processes where basically the vendors argued for position over each other as opposed to thinking about the innovation potential of it. And and then the cost of the routers is just going through the roof. You know, as a percentage of your total expenses, you know, it's exploding. And so I think one of the key drivers here was to basically shatter that black box ecosystem and create an environment with smaller, more modular components that people could mix and match, that they, you know, by decoupling the control plane from the data plane, you could have intense competition amongst the switch vendors and competition amongst controller vendors or partnerships if something like Open Daylight works. But basically by breaking up these black boxes into smaller little subcomponents, it allows a faster innovation cycle, I think was one of the key drivers that was coming out of the research community.
Yeah. And then Greg, and then I'll close because it's...
So our experience was simply that the researchers didn't know what they could do with what we had, and certainly didn't know or understand what they could do with more. And so we suspected that, and it certainly is true now in the implementation phase. So it's really, as I said in the presentation, it's bridging the communication gap, you know, as part of what the program is designed to do.
Okay, last from Greg, then I have to close because.
Thank you. For those who don't know, I'm Greg Bell. I'm the director of ESnet. So I wanted to take a stab at trying to answer that question, but also answer your earlier question about funding for the kind of activities presented in the second presentation that we had. So we go through a regular periodic review of scientific requirements for all the 6 major communities we serve. And so we sort of refresh our understanding of what communities are not able to do with the network on a regular basis, and we publish reports, artifacts. And what we find is that no scientific community is really optimally using the network. Each has challenges to use the network optimally. You might think that high energy physics is using it optimally, but they have many ambitions that, to use the network more efficiently and more creatively. We'd like to help them do that. But then some communities, and some of great interest to all of us just as citizens of the world, are making very, very rudimentary use of networks. So the climate community, the one that was highlighted, one of the projects highlighted in the EYR presentation, has massive data sets, small and highly flexible collaborations, data models that aren't nearly as fixed as in high energy physics, and progress in global climate science is actively being impeded by the inability to use the network effectively. And that's true in drug discovery and genomics and material sciences, so across the board. And so I want to I want to say that this presentation of 3 different modes of innovation, the panel was terrific, but I want to call attention to how important the second kind of innovation that we heard about, the EYR-style innovation, really is for our community. Not nearly enough money goes to this area. We weren't doing any of it 2 years ago. Now we have 4 people doing it, some of our best people, and I'd like to increase the size of that group by 5 times if I possibly could. And it's not about marketing, and it's not about PR. It's really about fulfilling what our mission is in the deepest and most important way. It's achieving better outcomes for our communities. And so I just want to highlight the EYR project and thank all the NRENs and participants who are working with us to implement those projects. They're really important. Sorry, that wasn't a question.
Yeah. Well, thanks very much. In fact, one of my backup comments, in case there were no questions, was exactly echoing that point there that Greg just made. In fact, what struck me most from Mary's contribution was the fact that you realized that they valued mostly the support they were given to do their work rather than any monetary contribution or anything else. The support they got was what they valued most, which I think is a key message to all of us here. Now, before I let you go, I have 5 announcements to make, which I just received via email. So, one is to vote on your favorite poster. 1. 2, your feedback forms, please. Number 3, extra events, BOFs tonight, please take part in them. They're very interesting. One is actually on user engagement as well, so